Okay, let me start with Docker introduction. Uh, so, so the first question arises: what is Docker? What are its benefits, and why do we need it? Okay, so I define Docker as a platform. Okay, I say it as a platform because it's not a final application, because it's only provide a platform so that you can deploy your application in an isolated environment within the same hosting operating system. So you have your base operating system, suppose CentOS or Fedora or Ubuntu, okay, and you have multiple isolated environments. So generally, in case of if you have your operating system, you won't get multiple isolated environments, because uh, one process can communicate with other process by inter-process communications. Okay, uh, so so there is only one isolated environment if you have the one operating system. But what Docker does, it provides you a multiple sets of isolated environment. So one environment is unaware for the other environment, and and they can't communicate directly. They have, if they want to communicate, they have to communicate via over the network, just like they are communicating between two machines. Okay, and that isolated environment is called containers. So we call them as a containers. So it's like a naming convention they have followed just on a shipping technology. Just like a chef used to use the kitchen and knives and technology naming conventions, and they used to be shipping technology. So we have multiple containers, and you have one ship and the Docker. That's why that Docker logo contains one ship and multiple containers of top of it, and each container can't talk to another container. That's the idea behind this Docker. Uh, so, uh, uh, but all this they are achieving it without the overhead of the running the new operating system. So you have a operating system, you install your Docker, and you create a multiple isolated environment. Okay, but each isolated environment, the process is taking, it doesn't Docker promises that you won't have the CPU or memory or storage overhead of the new operating system to get this isolated environment. So generally what happens, if you need an isolated environment, and if you are in virtualization space, you need to create a multiple operating systems. You need to do the hardware virtualization, and you have to create multiple operating systems on that. But and you can have you can have the multiple operating system as multiple isolated environment. But there's a problem. The main drawback of it is like every operating system has its own overhead to running as a full operating system cycle, but that Docker doesn't have it. So even if you have a base operating system as a CentOS, and you can have Ubuntu Docker container profile as different operating system. Okay, so you can do it also that. So it's like you are running a multiple operating system within the same operating system.
Okay, so hello. So in that case, when you're saying you can run, operating multiple operating system within operating system, so you can do that via virtual machines as well, right? It will be serve the same purpose.
Yeah, but that's what I explained it. If you spawn a new virtual machines, okay, it will have its own overhead. So every virtual machine will taking some only for the operating system purpose, to running the operating system. It will consume some RAM, it will consume some processor, main CPU and RAM. Okay, Docker doesn't. Okay, so it's like if you have to create a container in a Docker, which is an isolated environment, uh, you can do it within 2 minutes or 3 minutes.
So the thing is that you're saying that Docker will going to run without consuming any RAM or processing power. Then
Yeah,
how it will going to run?
Because they have a technology called they don't spawn a full operating system, but they mimic that they are running as a separate isolated environment. So it's like
but the thing is that let's say in a Docker images we just mimic one CentOS or Windows or whatever it is. So the idea behind is to deploy Docker container or something. You definitely going to process something into that, just like any Python code or some data analytics or some ETL tool, right? So once it's doing that, so without RAM or without CPU utilization, how it can process?
I think that you didn't get the point actually. The application CPU and RAM will be consumed, but the running cost of operating system is avoided complete.
Okay, so you're saying that it's one kind of microservice kind of stuff.
Suppose you have your any hypervisor, okay, which has a suppose a 4-core CPU, okay. So you can spawn, suppose the limitation, suppose we assume that the limitation you can spawn up to 10 operating system, okay. After that it won't do it because it's getting too slow. But in case of Docker, you can create within the same resource of hardware, you can create at least 50 to 60 containers. If you can create a 10 virtual machines, you can create a 50 to 60 containers. Okay. The second thing is the performance, because it doesn't have this cost of CPU and memory, the extra overhead of running the operating system. Definitely, application running cost is always there. Okay. But this to get isolated environment, the cost of getting getting the isolated environment is too high in case of if you go into a hypervisor space. Okay, so that's what Docker has the great advantage. Okay, and since we have this advantage, we are getting another benefits on top of it. Okay, we will explain later. So we can say that Docker provides a disposable environment. What does it mean that? So you have a container. So within the operating system, you have multiple isolated environment. So you can create it, you can run it. If you want to run some tasks in an isolated environment, you have some set of scripts actually in Docker. You run it, it will create it, it will run that script, run that task, and it will destroy it. So it's like if you want to unit test something, or if you want to do in an isolated environment, it can do that. So that's why someone said that one of the authors says that it acts like a disposable environment, and the run and the uptime of container is much lower than what you install operating system on a hypervisor. So if you have because it doesn't have the full operating system running, it just mimics and communicates with the host operating system.
Hi sir, I am sorry to disturb you. Sir, what is hypervisor? Could you please explain me?
Okay. Okay. So hypervisor is a technology. So what happens that what hypervisor does is it virtualizes this hardware. So you have one set of hardware. So if you have either going to ESX server or Oracle hypervisor or any hypervisor. So what it actually doing it virtualizing the hardware actually. So virtualizing hardware means it is virtualizing the network, it is virtualizing the CPU, it is virtualizing the RAM. So even if you spawn multiple operating system on top of hypervisor, everyone is getting the same resource and it is shared among them. Okay. In case of Docker, it is actually virtualizing your operating system. It is not virtualizing your hardware, because whatever resource that is allocating to this operating system is only getting used. So if you allocate suppose 4 GB RAM, only 4 GB will get used. So it is virtualizing this operating system. So and it is creating multiple isolated environment. Okay, so just like you have your workstation on your desktop, okay, you are creating multiple operating system. But if the hypervisor is not there, you can't create it. You can you boot your machine, you have got only one operating system. But in case of when the hypervisor technologies come, I think some 20 years back it came. So it started. You can have your multiple isolated environment and full spawn operating system within using the same set of hardwares. That's called hypervisor technology.
Okay, and another thing is that as you mentioned that it will not going to install the whole operating system. it will be bare minimum operating system. So can you please let us know means what exactly it will going to install means? What do you mean by bare minimum?
So they call it, they install the OS profile actually. So it's like, suppose you have installed Ubuntu, you have your base operating system as CentOS. You create a container with the base OS profile as Ubuntu. Okay, so that the commands that runs on the Ubuntu get translated to the CentOS. Okay, and that was done by Docker engine. It doesn't, you can't see it. It's all abstraction layer. So so whatever you are running actually, because you have some commands that can run on Ubuntu, but you can't run on CentOS. You have some commands that you can run on CentOS, you can't run on Ubuntu. That's specific to operating system, different flavors. Okay, so whatever you do actually in that operating system, so you mean that OS profile means that you have all the commands that you run on that profile, it already get there. Okay. Also, when you deploy your application on top of that container, you have all the features actually. So it's like that your container is communicating with the host operating system. It's translating your calls actually, because finally calls will every calls will convert into assembly language or a machine language, and it will run finally on hardware and RAM. So what Docker container does, when you do something, when you run some application or you type any command inside a container, it communicates to Docker engine. It's the job of Docker engine to translate that call to the base operating system. Okay, and then it's become base operating system. It translates to hardware, and this is like a communication channel, but it is not spawning a complete operating system. So it's not a full virtualization. It just mimics the virtualization stuff.
Okay.
Okay.
So the thing is that whatever command or whatever application is going to run on the Docker container, it will just pass the command to the host OS, and the host OS will perform the same.
In between there is a Docker engine. Okay.
Okay.
And it's the responsibility of Docker engine to translate that.
Okay, so Docker engine will translate that thing, whatever the Docker container command has executed to the host OS, and host OS will going to perform the task.
Yeah, and it's a Docker engine responsibility also to provide that environment as isolated, not affected by other containers, not affected by what's going on the host operating system.
Okay, so if we have a 10 Docker container within one host in operating system, and that is a CentOS, and inside that we have definitely Linux operating system different. So 10 application is there in 10 different Docker container, and you are performing some task on all 10 container. So all 10 containers, the command or whatever execution will be passed by 10 different Docker engine to the guest OS.
That's a single Docker engine that manages it.
Okay, and so how it will going to manage? It will be interleaved way, or suppose you are executing 10 commands in 10 Docker container at the same time.
It's like whenever you create a container, it creates a new sub process inside the Docker engine. Okay, and they communicate via that process.
Yeah, so if you run the same with different command but the same time in the 10 different containers, so it will pass that with the Docker engine or all the processes, sub processes to the host OS at the same time, right? There will be no interleaved processes.
Yeah, it will pass to the host OS, and Docker engine will keep that which process has been communicated back actually. So Docker
at the same time, right?
Yeah, at the same time, yeah.
Okay, thank you.
So you know the thread technology, yeah, it's like if you have a multiple core your CPU is multiple core, it can run at the same time. If you have a one core CPU, it will do the thread reshuffling. It depends on that. It's all the OS technology that you use.
Okay,
it applies to OS process also. It applies to sub process inside Docker engine also. Okay. So coming to
I have one question here. So can the host OS be a Windows operating system?
Yes, host OS can be Windows operating system, but their installation is a bit difficult, and the reason is because when our Docker technology started back, I think in 2012 it was first launched. I don't remember the year. It can be 2012 or 2013. So it started with all keeping all the profiles operating system, that container profile is only a Linux. Okay, so it becomes for Docker engine, it becomes very easy to convert from a one Linux command from the host operating system to the container one. Okay, still all the Docker containers works on a Linux profile. Okay. It now later what happened that Windows also tried to Microsoft also tries to integrate it, and they work together collaboratively and do it. So that's why Docker on Windows they have the extra process that takes to convert all these intercommunications between Windows to containers.
Okay. Okay. Yeah. Got it.
Since most of the production environment we see is a Linux server, so that's why I'm concentrating completely throughout this session only on Linux environment. Okay. So now we have this isolated environment. Okay. So what is this isolated environment? I can say that this isolated environment is my host profile. I can say that it's operating system which have the set of softwares also. If a Python is a Python one. Okay. So what Docker achieves further beside having advantage of this CPU overhead as compared to hypervisor, it also achieves your separation of your application from the infrastructure. So in the infrastructure means your operating system, your softwares, all the environment configuration. Okay, and you have your application just like you have a Python application, and you have a Python you have a Python SDK, you have a OS profile, and you have all the environment configuration also. Okay, so that's why since you have because you are writing a script to create this container. So every time you run that container, you run that script, you are getting the same set of infrastructure. So all the environment related problems has gone. So typically what happens that if you I'm not sure that whether you have worked on in that era or not. There has been you deploy your code on test environment, tester started testing it out, it passed that code. But when it moved to staging or production, because of some environment difference, it didn't run some of the code breaks actually, or some of the application module breaks. Okay, then what they used to do it, they used to compare the environment variables manually between your past test environment to staging or production, and they do that. Docker solves that problem. Okay, so you create so when the developer develops it unit tested is that exactly environment is moved to tester now do the enhanced testing, the complete integrated testing, everything what they want to do. Then the same environment, this isolated environment moves to staging and then to production. Okay, we don't move containers, we move images. Actually images is the blueprint of the container, so we deploy that images on some private registry or public hub, and we move that images. So this problem, once your environment is ready, you configured, everything is done, and it runs on worked on one place, it is going to work on another place. It doesn't matter whether that time your base operating system was CentOS or base operating system or Ubuntu or whatever it is, because it all depends on what your container profile is, and it remains the same. So this is one of the very good advantage of using Docker. Okay.
Sir, I have one question, sir. So suppose you created a Docker image in Ubuntu and you are going to deploy in CentOS or Red Hat. Is
it doesn't
any?
Matter.
It doesn't matter. Okay.
It doesn't matter.
Thank you, sir.
You can, because if you see this Docker hub, you can have the multiple. It doesn't never mention that it's going to work on one Linux server. It is dependent on some Linux server. It is It is the abstraction layer, because it all the what does it matter is that what OS profile that image contains or container contains.
Okay. Even sir, even if you created in Ubuntu and you are deploying Windows OS, any issue or it will be?
There won't be issue. There won't be issue, and if there will be issue, it will be have. Yeah, sorry for it. If you have some issues, then it's a Docker responsibility to fix that issues.
Okay.
It was not that every time it worked. Actually, at the start, there were lots of problems. Developers, testers, and the admins used to file a bug on the Docker, and they used to fix it after in the next release. Okay, so it's
Okay,
not
sir.
our responsibility, because the abstraction layer is completely responsibility of Docker engine. Okay.
Yeah, sure, sir.
Okay. Okay. So since your infrastructure becomes immune to the environment problems, and you have separated your application from the infrastructure, your deployment becomes very faster. Because you don't have to reconfigure. What happens that when you change some configuration, or you have the Python SDK, or you have the Java SDK, and you have Java application, you added some patches on top of it, you upgraded that version. So you upgraded that version. So when the Docker is not there, what is to do that when you move to test environment, some of the test folks upgrade that one actually, because that was instruction that was given. Okay, you upgrade that version. Then you on the staging environment you upgrade the version. So it becomes the complicated. The deployment becomes slower and slower. But when you have the developer has created, or even the Docker admin or the DevOps admin has created that images, and once tested on one environment and it's working, you just ship that images. Okay, you deleted that container, delete that images, you upgrade that images. That's all. So deployment becomes very faster. Okay, to understand that the concept of Docker, DevOps, and all that this technology, how it is evolved, I will take you back some 20 years back, the software environment culture, because some of the folks might not have worked in that era, but that will help you to understand that why the DevOps culture has evolved, what are the problems they are facing, and what are the challenges they fix by moving to DevOps culture. Okay, so first era I want to discuss with you guys is like the era between 2000 to 2010. Okay, so they used to, most of the time people used to follow waterfall model. Okay, around 2007 or 8 they started moving from waterfall model to agile methodologies. Okay, agile model. So waterfall model typically says that, okay, client has given your requirement. Then what we used to do, that we used to do requirement gathering, then we used to design the compliant application, we develop it, we test it out, okay, then we give to a client for acceptance testing or deploy on the production as they are demanded. Okay, there's a problem in that waterfall model. The people face actually face between client and customer and a software company is that the interaction becomes very low. And typically it start happening that whatever requirement you sending, whenever you get the end product after 3 months, 6 months, it becomes very variable. Okay, so so client is not aware, client has not when client see the final product, he said that, okay, these are the features, you didn't understand that requirement, so there were lots of rework started. Okay, so that's the time where they started moving from waterfall model to agile methodologies. So agile methodology says that, okay, I won't give the complete product at the end. I will start delivering module by module in a sprint, or in a some set of weeks. So might be 2 weeks, might be 3 weeks. That depends on the agreement between companies and client. And we used to deliver small modules, and so that client is aware of the progress, and they can commit it out at the early stage. Okay, this change this feature, because when a product has been finished or it has been developed, the rework becomes more actually. So they're shifting from waterfall model to agile methodology, but that comes with a problem. So every 2 weeks or 3 weeks, you are delivering the code to the customer. Okay, that means you have to test it out, that code. You have to reconfigure your environment. You have to do all the manual work for configuration, all this stuff. Okay, so the problem starts there. So because every 3 weeks, most of the time is getting consuming in doing this configuration, doing this retesting, doing this the deployment. You take the build, you deploy it in the build also. All the problems started actually. Okay, so what Agile requires is a frequent delivers. Then the problem starts with this the loss of time that is getting consumed every 2 to 3 weeks has added on the problem. It is getting delayed the project, the final product. Okay, so that's the time around 2010 or 11. People start thinking that okay, we have to concentrate on automation. We have to automate everything from end to end, and this automation should be working each time. So whenever you deliver a code, it should automatically start building that code. That's where Jenkins comes. So what Jenkins is to do, whenever you deliver code, and you can configure Jenkins that after each change set you delivered, a developer delivers to the repository, it can trigger a build, it can do the unit testing. So you know that okay, which set of code has this problem if the unit test fails, and what. So that's one of the advantages, that it automatically builds that. So all the unit test problems gone. Okay, then we don't want to deploy on test environment manually, then on the client side manually. So we started automating that environment concept, and there comes Chef and Ansible. Both does the same work, have a different technology by different companies, but the final goal of that Chef and Ansible is that they want your deployment and environment to be automatic created. Okay, so there comes the Chef and Ansible. Then comes the Docker. Docker doesn't do the automation stuff, but it provides your environment where you can deploy your application, and it guarantees that if you're running on one environment, it will work on the other environment also. So if you're working on test environment, it will going to work on it. So that's the time where after 2010, this culture started, and people started telling a common name called DevOps, and it's more about automating all the stuffs. Even after you deploy on a test environment, the integrated testing has been starting getting automated. So you don't have to the tester doesn't have to do anything. You just have to trigger that okay, deploy on test environment. All the integrated test cases will be executed, and you will get. And if the issue, they can create the defect can be automatically also created and assigned to the developer. So these cultures shifted because we shifted from waterfall model to agile methodologies. We have to do that because we have to deliver every step in 2 weeks, 3 weeks, or a month. We have to deliver more frequent. So we have to do that, and that's where DevOps culture comes. So nowadays we hardly see any manual testing. We hardly see any manual deployment, and even some companies do that. They are still started migrating it out. So that's why DevOps has a huge advantage over it, and now it becomes a mandatory skills even for a developer also, even for a tester also, even for the admins also. Okay. So we have already discussed that one. Okay, so I move to next slide. Okay. Okay, we have already discussed one. Okay, so where Docker fits in the DevOps? So DevOps does the deployment also. DevOps does your build also. There does your configuration also. So Docker fits both in the deployment purpose also and the configuration purpose. By configuration, I mean that it is configuring the environment. By deployment, I mean that because you are deploying your application on top of container, so it is a part of your deployment. You can say that in Docker parts of deployment. Okay. Okay, we have discussed this also because some of the folks have asked this question, why we require container via hypervisor, and this is a snapshot where I'm explaining that if you have virtual operating system, there are two sets of operating system that you require. Okay, you require a host operating system. Okay, then on top of it you require a hypervisor layer, that is a software. Okay, and the same thing is a Docker engine for the containerization technology, and then you require a guest operating system. The Docker doesn't have the guest operating system. Okay, it only uses and it uses the containers as a guest operating system, and you can deploy application on top of containers.
Sir, I have one question. What is the difference between guest OS and host OS, sir?
Okay, host OS is the primary OS that sits on the hardware, and the guest OS your virtualized OS. Just like if you have even if you have a desktop, you have a Windows, that's your host OS, and you install any other VM player or OVM player. Okay, that becomes your hypervisor layer. Then you install another operating system on top of it, just like you install CentOS, Ubuntu, whatever you like. That becomes the operating system.
Okay.
Okay. In case of Docker, you have your suppose you have Windows. Okay, you have a host operating system. You just install a Docker engine on top of that your Windows machine, and you can have your multiple containers. Okay. And similar case, if you go to the ESS server or the servers which is deployed on production also. So even ESS server has a thin layer of host operating system there, and that's why you can see all the screens and all the manage that all the virtual machines. Okay, and then they have the hypervisor software, and then you can install all the guest operating system. And in a typical production environment, what we used to do that we used to deploy this container inside a virtual machine. Okay, so inside a guest operating system. The reason is because you require a hardware. Okay, and every hardware vendors, the server vendors, used to provide you the host operating system and hypervisor software already installed. Okay, so what you do that you install any guest operating system, suppose CentOS, Ubuntu, whatever you like, and you deploy multiple containers on top of it. So it acts like a 10 different isolated environment or 10 different you can say that virtual machine, but it's not a fully spawned virtual machine. It's just you mimics the virtual machines virtualization technology. Okay, I've already explained this stuff actually because the question has come up before we get to this slide. Okay. We have already explained most of the stuff here, but I can repeat because since Docker separates the code from infrastructure, developer can concentrate on the core application issues. We don't require the environment issues, every problems. Developer doesn't need to get involved. Now this issue has gone. Okay. In Docker, we ship containers, or we can say that we ship also images along with the application. That due to different environment issues, that issue will not be there. And it virtualizes the host operating system rather than hardware, so it is much faster because we don't have the overhead of the running the fully spawned virtualized operating system. Okay. Since we don't need to run a fully virtualized operating system, so we don't require that overhead. We can run more number of containers than you can run a number of virtual machines on the same set of hardware. Okay, that means that means we can if you have a monolithic application, you can break that application into multiple microservices and deploy as an independent deployable, where you have an independent set of build rules, whether you have an independent set of deployment rules, you have a separate set of images also, and you can deploy as a different standalone multiple microservices. Okay, so because it has an advantage, when you break a monolithic application into microservices, that means you break the application into multiple parts. You have an advantage because suppose you have a application server which is have the UI interface also, you have your middleware also, you have your application layer also, you have web server also, you have application layer also, and you have some communication with outside also. Okay, previously what used to do before Docker come, that you used to deploy, you can only deploy as a single monolithic application. Okay, with have the container technology, because it doesn't require much CPU overhead, what architect used to start doing, that is start breaking this application into multiple small microservices. Okay, the advantage that it is independent deployable. Okay, so if you have some defect on suppose backend only, on the application layer only, or a subset of modules that is independent deployable, you just need to replace your application portion of that portion. You don't have to redeploy your complete application. Okay. The another advantage is that
I'm sorry, sir. Sir, can you explain once more? I couldn't understand completely last what you told.
Okay. Okay, so you have a monolithic application, and you have break it down into multiple independent deployable microservices. Okay, now instead of one application, you have your multiple containers running, and each container has each independent module. Suppose there is some issues, some defect in one of the module. Okay, so you only need to redeploy only that portion. You don't need to redeploy the complete set of it. Other can run. Okay.
Okay, sir. Thank you, sir.
So that's the advantage, that, and also you separate your problems individually. So this is the one of the advantage.
So the thing is that when you're saying monolithic application, so means you're considering a three-tier application as a monolithic application, or you're considering everything as a monolithic application?
I'm considering a web server as a monolithic application server as a monolithic application, or any application that can be divided into individual components. Suppose, for example, you have your banking application. Okay, it does a transaction. Okay, it also generates your alerts to your mobile. Okay, it has a different. It has a one more feature, that whenever you transact via online, you transact via ATM machines. Okay, so you can. So if you have a single application deployed, okay, which used to happen 10 years back, or when this container technology didn't come, you have your single application. Now, if you can divide this application on different three sets of multiple small applications. Okay. You have that has been independent deployment as a different Docker containers. If you have a problem, some bug or something in while generating your alerts, the performance issue or any issues, okay, developer just need to fix it out that only module. Tester only need to check test it out that only module, and the deployment happens only for that module. Okay, you bring out that only container.
Okay, so when you mentioned that banking application or any other application, so those banking applications have front end, middle layer, and as well as a database, because whatever you are doing a transaction and all those things, it has to go through the middle layer and it has to go to your database. So in that case, how you are breaking that application?
So it all depends on your it depends on, it varies definitely going to vary between architect to architect. But if I am there, I would divide into different way actually. Okay, the front end I will have a single different container. Okay, the middleware, that's a web server, I will have a different container. Okay. So the front-end container won't have this your SDK for your web server. Okay, The middleware doesn't have your SDK for your front end. Okay, that container. Okay, and it's not about only dividing the application. You are dividing the software that is required to run the entire application also. Okay, the base software. Now backend, I will divide into a multiple different individual functionality modules. Suppose if a net banking one, I will have a different module. If I can separate it out. If you have suppose just like I said that you generate alerts for that, you would separate it out that is different module. Okay, which will go into the alert system. For ATM transaction, you separate it out the different module. So I will create 3 and to 5 containers in a typical.
Okay, for the back end you will create 3, and okay, the front end is 1, and
front end middleware will be a single.
Middleware is 1. Okay.
And while doing it in a real time, because you have the monolithic application already created, developer has to rework some of the code because your web server will have to now your UI has to communicate with the web server has to communicate with your the actual modules, the main transaction modules or alert modules, whatever you require. Okay, so you have to do some rework on the code actually, because it's an old application, because it was not designed while keeping this containerization technology in mind, and they have I think they have already started doing it out. They have started thinking it out. Okay. Nowadays, they call it, if you are developing from scratch, they call it a cloud native application. Okay. So, and the purpose of saying that cloud native application also includes this feature of containerization also. Okay. So, they are going to deploy on a particular set of containers. Now, every new application, they are not from the scratch, they are starting developing while keeping in mind that, okay, I have to deploy inside a container. It depends on the capability on the architect or developer that how many number of containers they can break it out, because it has a advantage of breaking it out into multiple microservices, because every environment will, because now they have to take care only a subset of that environment if the problems occurs.
Okay, thank you.
Okay, one of my question about this.
Okay, yeah.
So when it's, this is Tushar. So whenever we talks about the monolithic application, so let's assume that it's a banking sector, APIC or any FNS application over there. So how could you be possible that you can containerize it with the complete application, or it will be segregated with different parts?
So what happens that generally if the application is huge, generally they use into multiple phases. Okay, so if the application is huge, might be in the first step they can divide it between UI web application and the backend module is single deployment single container. Then they can slice it out multiple containers based on different individual functionality. So but it's a small application, you can do it at one go. In my case, when I did it for one of the application, that was not a banking application. Okay.
And what will happen if the application is so big? So let's assume that APIC it's having something 4 to 5 banking modules, and it's the binaries comes around 14 GB in some vortex, and after growing it increases very on high. So in that case, so we have to segregate in multiple containers, or what exactly? How it works? Exactly?
So it's like that. In that case, generally, because it will take lots of time to containerize it, might be a year time. Okay, and it requires testing, because you don't want to break the existing functionality only for the Dockerizing purpose. That's actually a crime. Okay. So because if something is working and you containerize it and it breaks something, that is not acceptable for any client. So generally, what is to do that is the application is huge and it's a bigger and it's a multiple modules. So we do it in phases. So it's like just like I said that you divide it how you want to do that. Okay, either you start containerizing a different backend modules, okay, in a separate individual container, and keep UI and web app part as a single container. Then in the second phase, you divide between UI, web app, and the backend communication layer as a separate container. So it depends on your choice, or it depends on architecture approach that how we plan to do that. You can do it 2 phases. If it is so much use, you can do it in 3 phases also. But every phases, your number of containers is going to increase.
Okay.
In my case, where I did it, it was not a big application, but yeah, it automates all the cloud. Okay, it automates all the provisioning of this virtualization layer, and it has a multiple modules. We break it out into multiple microservices at one go, and it took around 4 to 5 months of some rework to do that. But we did it in a single page actually, and we released as a separate new version, major version.
So it means that can we take the entire banking solutions to the cloud with containers?
I would suggest that no one is going to take that much risk. So because in case of banking,
or any development part, or any development parts. Let's assume some development server for banking solutions. Can we take it on the containers?
Yeah, you can take
on the cloud.
Okay. See, it is the responsibility of the software vendor. Okay.
Okay.
To provide the images for that, because the previously software vendors used to provide just like a web server, they used to provide for a Windows installable, Linux installable, Mac installable, and whatever your operating system you choose, Spux or whatever system. Now they also providing nowadays they are providing Docker images also. Okay, whenever they release, they release as images also. Okay, so and there at least I think I've not counted on a Docker Hub that there will at least might be 1 million or more than images already there. They are all published by software vendors, different software vendors. So MySQL will do it whenever they release it. They release images on top of that also, apart from their standalone application.
So is this Docker image chargeable?
Depends on software vendor. Some most of the images are not chargeable, but it all depends on software vendors, because if you are using open source free software and they provided images, there is but definitely just like you need a support for that. If you have a web server and deploying a banking application, any software that is getting deployed on a banking sector or insurance sector or it's like critical environment, they used to buy their support, and the support is same. Actually, you deploy on a container or you deploy as a standalone. You have to buy that.
Okay, one last quick question. Suppose I create 25 containers and develop my software code for a banking application. Can I be able to join all these containers or the codes of these?
Yeah. So reason is that Docker provides you isolated environment, so you can't do same level of you can't directly communicate it, because that's otherwise what the purpose of isolated environment. Okay, but you can communicate via network. So it's consider each container as a standalone operating system. Okay, and there are technologies that there are approaches that how we can communicate with each other, and that we will do it. There's one workshop that I have designed only for the purpose of breaking a sample monolithic application into microservices, and I will show that while monolithic application doesn't require to communicate between modules, doesn't require extra thing. What extra stuff you need to do when you deploy it as an individual component and microservices. There are multiple approaches, there are multiple designs perspective for that, and we will take care on in the workshop.
Yeah, thank you.
Yeah. Okay. Okay, we have completed this one. I plan to complete Docker installation part also, but I think we don't have time left. So the next session will be on Monday at 8:30 p.m. India time, For the folks which are outside India, they can convert their timing. The timing remains the same. The next session will be on Monday, that is 9th of September. Then Wednesday and Friday. Now we'll continue on Monday, Wednesday, Friday, and it will take around 1 month, 1 week to complete because there are total 15 sessions.
So it will be on the same time, right? Just like today's?
Yeah, it will same time. And the next session is on Monday, 9th of September.
Okay, no problem. Thank you.
Sir, could you please share the slides so that it would be good for revision, sir?
Yeah, I will share the slide.
Thank you, sir.
Yeah, thank you.
Sorry, I didn't get. So how long will take the whole course? Sorry, how many weeks?
So this course is it will take 12 to 15 sessions. I think the number of questions are high, then the number of sessions will become automatically high. So considering the 3 sessions per week, you can divide it out. It will take a month or a 1 month or 1 week.
Okay, thank you.
Yeah, thank you.
Thank you.
Yeah. If we don't have further questions, we can drop now, and we will join again on Monday.
Sure. Thank you.
Yeah, thank you.
Thanks. Yeah, thanks. Yeah. It was a nice interactive session. Thanks to all the folks.